All right, guys, welcome back. Similarity Day 2 practice. Let's see what we've got here. All right, here at the beginning, proving triangle similar. Are triangles similar? If so, write the reason. Here, all we have are side lengths. There's no angles involved. We want to make sure that we're comparing the correct side lengths. The first triangle has sides of 8, 12, and 16. The second triangle has sides of 6, 9, and 12. If there's any chance for these to be similar, then the corresponding sides would have to be small with small, medium with medium, and large with large. So we're going to put 8 with 6, small with small, 12 with 9, middle with middle, and 16 with 12, big with big, and see if these are proportional, meaning are they the same ratio. Well, the first one, that is 2 times 4 over 2 times 3. That is 3 times 4 over 3 times 3. And that is 4 times 4 over 4 times 3. And yes, all of those are the exact same ratio. So we know that these two triangles are similar because all three sides have the same ratio, SSS. Then they want us to name it. WIZ is the one they gave us. I to Z is small to medium. We have to do the corresponding order. We have to hit small, then medium. Small 8, then medium 12 would be DOR. Wiz and Dorothy, right? You can still be with the wizard. What you've worked and waited for. You can have all you ever wanted. Anyways, sorry. I can't want it anymore. All right, sorry. Here we have another triangle here. Another set of triangles. We have angle T is equal to angle M. So we have one set of equal angles, and then we have these vertical angles. And vertical angles are going to be equal. So we have two sets of angles matching two sets of angles, which is a guarantee that the third set is going to match. We don't have to write all three, but we need two of them. AA. Boom. Killed it. But then we have to name it. So they said TIN. T to I is a 1 to a 3. And then N is a 2. So we're going 1 to 3 to 2. So we need to go 1 to 3 to 2, which would be MAN, the Tin Man. Something has changed within me. Something is not the same. Oh, man, I love Wicked. Sorry, guys. Here we go. Next one. We have vertical angles once again. So this could be SAS, but we have to verify that the sides are proportional. The sides of the first triangle are 10 and 18. That's small and big. 10 and 18. That's small and big. The sides of the second triangle are 12 and 15. Oh my gosh, I keep making fractions. 12 and 15, small and big. So in order to have any chance, 10 small would have to go with 12 small. 18 big would have to go with 15 big. This is 2 times 5 and 2 times 6. This is 3 times 6 and 3 times 5. Those are not the same ratio. 10 gets bigger to become 12. 18 gets smaller to become 15. These are not similar triangles. It's not even NEI. We do have enough information. We know they are not similar. All right, moving ahead. We have triangle, or not triangle. It looks like it's a pentagon. We have James and Ethan are similar. That little symbol means that they're similar. And we need to watch the name, guys. We have to make sure they didn't flip it, turn it, rotate. We got to make sure that the corresponding pieces are in the right spots. JA goes with ET. AM goes with TH. So looking at the first one, J to A to M. Start in this corner. J to A to M. Matches, what are the corresponding pieces? ETH, E to T to H. And if you get the first two sides in order, the rest of the sides are going to go in place. That means 6 does not go with 10. That would be the number one mistake. Based off the name, it is 5 and 10 that go together. That means we have a ratio of 10 to 5. 10 to 5 reduces to 2 to 1. That means for every 2 units on Ethan, there's 1 unit on James. So starting with JA, 5 times 2 is 10, 4 times 2 is 8, 8 times 2 is 16, 9 times 2 is 18, and 6 times 2 is 12. So I just went around and I kept doubling each one, asking about their specific ones. Like they asked for AN, like look at AN in the name. AN goes with ES. So ES is 9, so 9 times 2, AN is 18. And then the same thing with HA. HA goes with ME, so go to ME 8, ME times 2 is 16. So however you want to think about it, we know the ratio is 2 to 1. You have to make sure that you understand 5 goes with 10. If you don't understand 5 goes with 10, you're in big trub. All right. Then we have some area questions, some perimeters, some stuff going on here. It says, lake don't fall in our pit has a surface area of 255. So I'm going to say the area here is 255. The number of students that I have seen write the wrong number. This is 255. It is not 225. I see it nonstop. It's not something that happens all the time, but for when I give 255, this number specifically, I see 225 all the time. I don't know. It's weird. It says, Lake, look at these lily pads, has a similar shape. So the shapes are similar. The similarity ratio of don't fall in our pit to look at these lily pads is 4 to 5. So they're saying for every 4 units on the first lake, there are 5 units on the second lake. So to work with area, remember that the similarity ratio is the ratio of linear measurements. To get the area ratio, we need to take the similarity ratio and square it. That would be 4/5 squared, which is 16 over 25. So we taught this in the last lesson. This is a high miss rate on SATs. To work with a 2D, 2-degree measurement, you must have a 2D, 2-degree ratio. So we have to square it. So 16 over 25, that's our pit over lily pads, equals 255 our pit, and we'll call lily pads X. So that's our setup. Now it does specify down here, or no, somewhere, that we are going to round to the nearest thousandths. So I am going to pull up my calculator, but we're going to cross multiply. That would be 16x, because nothing here reduces. 25 times 255 is 6375. And then we're going to divide by 16. And this one specifically asks us to round, so we do need to round to the nearest thousandths. 398, that would be 438 if we were to round that to the nearest thousandths. So that's the surface area portion of the question. Then they ask us about perimeter. They say the perimeter of look at these lily pads is 215. So this perimeter is 215. What is the perimeter of don't fall in our pit? Well, the perimeter ratio is equal to the similarity ratio. They're the exact same ratio. So we're going to use 4 over 5. So 4 over 5 is top over bottom. This perimeter, we'll call it X, or we've already used X. Let's call it Y. So we're going to say 4 over 5, our pit over lily pads, equals Y over 215, our pit over lily pads. And this does reduce. So 5 and 215, that'd be 20, 40, that'd be 43. So Y equals 160 plus 12, it's going to be 172. Cross multiply and solve, but please practice reducing as much as you can. Boom. Perimeter ratio, area ratio, similarity ratio. Really important you understand the differences between all those. Look at the cute frog. Okay. This picture has a high miss rate. Yes, it does. Lordy. Here we go. I'm excited. I'm pumped. First, we have parallel lines. And one our rules for parallel lines is that the non-parallel sides, the sides that are not parallel, call them the transversals, the non-parallel transversals have the same ratio for all of their parts and for any combination of their parts. So this entire side and over this entire side is also the same ratio. So how are we going to solve this? There's a few ways you could do it. First, let's set it up as 14 over y, top over bottom, equals 7 If this whole side is 20, we could call this 20 minus y. We've gone over this before. Let's go over it again. Like if this was 6, wouldn't you do 20 minus 6 and call that 14? It's not 6, though. It's y. Do not put y minus 20. Y minus 20, that's a small number minus a big number. No, 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 no. It has to be big minus small. So this is the most common way you're going to see students do it. But I would challenge you to recognize this. You could also do 14 over y equals 21 over 20, and you would be correct as well. I did top over bottom equals big top over big top bottom. Remember in the original notes, we can do any combination of the non-parallel sides as long as we do the same combination. Both of these proportions are going to get me the same answer. This one is the easier one to work with. So I'm going to work with the second one, but they are the same thing. They represent the same thing. So this, let's see, does anything reduce? 7 times 2, 7 times 3. So that's all that reduces there. So we would have 3y equals 40. So y equals 40 thirds. Got it. And then we are trying to solve for x, which is where we get a lot of our mistakes. A lot of our mistakes. Here we go. So we're going to solve for x. To solve for x, we have to focus on the triangles. And if you need to redraw the triangles, then do it. There's a small triangle that is 14, 10 minus x, and y, which we just solved for, is 40 over 3. And then there's a big triangle that has sides of 25. How long is this entire side of the big triangle? 21. And then there's this side, I don't even care, but it would be, what is it? What is the big side? 20. We know that side's 20. Okay, so we are going to do a setup involving x. Our setup needs to be 10 minus x over 25, that is small triangle over big triangle, equals, which one of these looks better? The non-fraction one. So yeah, we're going to do this one. Equals 14 small triangle over 21 big triangle. If you're using the actual parallel lines, you have to focus on the similar triangles. The parallel lines do not have the same ratio as all the little pieces do. You cannot do the same ratio. You cannot do 10 minus x over 25 equals 14 over 7. You can't do that. And it makes no sense. To go from 14 to 7, you're getting smaller. Does 10 minus x get smaller or bigger? It gets bigger, so it makes no sense. This is the only setup I like here, guys. Also, one quick note I should have said earlier is like, how do we make sure you have the same setup as me? Did you do the same cross products? If you did, you wrote the same thing I did. Check your cross products. Okay, so let's actually solve the proportion now. Reduce 14 and 21 is 2/3. And that's all we can do. So then we cross multiply. 3 times 10 minus x equals 2 times 25. That is 30 minus 3x equals 50. You have to remember to distribute when necessary. So I need to solve that. That would give me 3x on this side and negative 20 over here. So x would equal negative 20 thirds. Boom. And I like it. Is negative okay for x? Yeah, plug in the negative here. 10 minus negative 20 thirds is 10 plus 20 thirds, my friends. And that's 50 thirds, so we are okay. We're okay. I'm okay. Are you okay? We're okay. And there's your answers, negative 20 thirds and 40 thirds. Feeling pretty good about that. I know you are too. All right. The ratio of the angles, these have been reduced already. I'm not doing the whole lesson again, but the idea is that we're going to call x the GCF, and we don't know what the GCF is, but we do know that if we do 4 times x, 6 times x, 20 times x, and 15 times x, if we multiply all those times x and add them together, the original shape is, we're talking about angles of a quadrilateral, so we know in the original numbers they have to add up to 360. The angles of a quadrilateral always add up to 360. So 20, 30, this would be 45x equals 360. Divide by 3, I don't know if that is directly. Divide by 3 would be 15 and 120. Divide by 3 would be 5 and 40. Divide by 5 would be 1 and 8. So x equals 8. So once we know x equals 8, then we have to answer the question. So x is 8. That is the GCF. It's what is the difference between the biggest angle and the smallest angle. So the biggest angle would be 20 times 8. And the smallest angle would be 4 times 8. So 160 minus 32 is the difference, and that is 128. Boom, shakalaka. Love it. Triangle ABC has an angle bisector called BD. Angle bisector. AB is 15. BC is 20. AC is 24. Find AD. The thing you're looking for is where you should put the X. The only way to get through this question is to put that X in the correct place. And then understanding that this spot is 24 minus X. Right? If this was 10, you would do 24 minus 10 and call that 14. It's not 10 though, it's X. So the other location has to be 24 minus X. Once we do that, the angle bisector rule says that the two sides, that's 15 and 20, the two sides that touch the angle bisector have the same ratio as the two pieces of the third side. So there's our proportion. So reduce 5 times 3, 5 times 4. That's all the reducing we can do. So then we have 4 times x equals 3 times 24 minus x. So 3 days is 72 hours. So 7x equals 72. So x equals 72 over 7. Beautiful. Lots of parallel lines. Every section is the same ratio. The non-parallel sides have the same ratio over and over and over. They tell us BF, that's all of this, is 10. DC is 3. And AD is 12. Find BE. Several ways to do this. First way that is probably the most obvious for most people would be to call this 10 minus x and to say x over 12 equals 10 minus x over 3. Perfect. Check your cross products. You can do it different ways as long as you have the same cross products. Or another maybe less obvious would be is you know that this is 15. 12 plus 3 is 15. So you could do x over 12 equals 10 over 15. Remember, you can do any combination you want as long as it's the same combination. So these two combined would go with those two combined, 10 and 15. These are both just as good. You're going to get the same answer both ways. I think this one's easier to work with. This is 5 times 2 and 5 times 3. This is 3 times 1 and 3 times 4. And I get x equals 8. You would get the same answer here if you did that one correctly. More parallel lines. Make sure you fully understand this question. Yep, don't come into my quiz and test not knowing everything about this. We're just going to kind of verify them real quick. Bottom of the small, bottom of the big equals, so, oops, reading it backwards. It's F over E, that's big over small, equals A plus B over A, big over small. If you're using the parallel lines, you have to go off the triangles. That's correct. C over E, that's right over bottom. would need to equal right over bottom. Nailed it. Perfect. E over F, bottom over bottom, equals A over B, equals left over not left. That's not it. Can't do that. Can't do that. Can't do that. Can't do that. If you're using the parallel lines, E over F would be A over A plus B. If you're using the parallel lines, you better focus on the triangles. As a matter of fact, if you need to, draw the triangles. The triangles are A, C, and E. The bigger triangle is F, C plus D, and A plus B. If you're using E and F, these are the only options you have. So if you do E over F, then A would go with A plus B. That's your only choice. So that one's wrong. B over A plus B, so B over A plus B equals D over C plus D. If you can do any combination of left over right that you want. This is tough because the parallel lines and the non-parallel lines have different things that are controlling them. The parallel lines are a part of the similar triangles, and you have to use similar triangles. But these little pieces are all the same ratio, and we talked about in the original lesson, you can do any combination of left over right that you want. So if you focus on the first part where it says B and A plus B, if I do bottom over whole side, I got to do bottom over whole side. As long as I do the same exact corresponding order, I'm in good shape. F over E, now we're talking about triangles again, equals D. There's no D on this triangle, guys. So no, no, no. C over A, that's right over left, equals D over B, right over left. Yes, non-parallel lines, we can do any combination we want. A over A plus B, so left over entire left, equals D. Oh, I don't like that. This was upper left. This is lower right. It would have to have been C to match A. So that is wrong. No, D does not match A. A over B, top over bottom, equals C over D, top over bottom. Beautiful, love it, yes. And then A over D, oh, already wrong. You can't go top left with bottom right. Those are not corresponding pieces. These are both on the left, I can put them together. These are both at the top, I can put them together. But top and left and bottom and right, All right, and then finally, I think this is the last one, yep. Triangle redraws. I recommend you use the good strategy of redrawing the triangles. First order of business is realizing that both triangles use that corner. Small triangle uses corner R, big triangle uses corner R. Second order of business is to redraw the triangles in a helpful way. I recommend tracing or using the big triangle as your guide. So the big triangle is the one I base everything off of. And the big triangle has a 2- bottom left and a 1- at the top. I'm going to go ahead and put a 3- in the third corner. The small triangle would have a 3- here. What I do now is I take that and I literally do a dupe. Triangle dupe. You can keep it the same size. You can make it smaller. It doesn't really matter that much. I'll make it a little bit smaller. And we make sure it faces the same way. Now we get the letters on there. The big triangle, the 2 arc is R. The 1 arc is T. And the triple arc would be this one. And the triple arc is U. The small triangle, the 2 arc is R. The 1 arc is V. And the 3 arc is S. So S and V switched. They flipped. And you have to account for that, and that's what makes these so hard. All right, then let's label. They said RS equals up the original, or cut out some of that. Let's start again. Okay, so we get this, and now we got to get the numbers in there. RS is 3, RV is 4, RT is 5. Okay, I think I skipped the 4 last time. RT is 5, RS is 3. Notice S and V, they switch positions. So we have to make sure that we do that the sides switch positions. That means these sides are going to flip-flop. So RS is 3, RV is 4. Okay, TU is 7, TU is 7. Find SV, SV is X. Do I now have something to work with? And the answer is yes. Woo! Yikes. We can now do 7 over X, right over right, equals 5 over 4, left over left. Nothing reduces. 5X equals 28. So X equals 28 fifths. I'm going to try to cut out that junk where I was messing up for a second, but I'm sorry about that. You guys have a great day. I'll talk to you next time.